Gotthard Base Tunnel located under the Swiss Alps. The initial sketches for the project began in 1947 but was put on hold in the 70s due to the recession. Construction began on November 4, 1999 and was completed on June 1, 2016 and was fully functional on December 11, 2016. The tunnel was paid for by Switzerland and was endorsed by its citizens. The main constraint and purpose of the project was to reduce freight and passenger travel times. Previously, they were depending on the old Gotthard Railway, which dated back to 1882. With the new tunnel, they can transport 260 freight trains per day compared to the 180 on the previous line. As well, it is the world's longest and deepest railway tunnel, measured at 57 kilometers in length and 2.3 kilometers in depth. Due to the high value of performance and the scale of the project, these are also the reasons why it would be acceptable to exceed the budget. Aside from their priority of generating economic growth by enhancing freight and passenger transportation, the creation of the Gotthard Axis will also mark one of Europe's largest environmental protection projects aimed at preserving the Alpine area. For technology, engineers had to dig and blast through 73 different kinds of rock. More than 28 million tons of rock was excavated, which was then broken down to make the concrete used to build the tunnel. Tunnel boring machines carried out 80% of the work in the main tunnels, and conventional blasting methods were used for the remaining 20%. To save time and money, the tunnelers worked on different sections of the tunnel at the same time. Workers, material, and machinery were transported to the construction sites in the mountain via access galleries and shafts. The construction lasted 17 years, during which 2,600 people worked non-stop, with workers doing 8-hour shifts each.
With a project of this size, which includes over 2,000 employees, there are many stakeholders involved. For the success of any project, the project management team must select what key stakeholders need to be consulted with and who needs to be informed. So of all the stakeholders in this project, we selected 4 based on the importance of the success of this project. We chose to consult with the Swiss government and Swiss Federal Railways. We chose to inform the general public and Alpine Initiative. So with the Swiss government, they were the major financial provider and driver for the project. Consultation with the Swiss government is a must. Their wants and needs need to be heard and met throughout the project. The general public is a major stakeholder in this project. A percentage of their tax money are funding the project, so it is smart to keep them informed of the project's projected schedule, budget, and quality in order to keep stakeholder satisfaction high. After construction, SBB Rail will take over as the main operator of the tunnel. This company was chosen to be consulted with because they're using the tunnel every day and need to have their concerns about the tunnels met, as well as be aware of specifications and regulations inside the tunnel. The last stakeholder is the Alpine Initiative. This is an environmental group that wanted less noise and air pollution in the Alps. It is critical for stakeholder satisfaction to keep such a large and influential group such as this informed of the project. When you're building the largest tunnel in the world, one should be prepared for various risks throughout the project. We worked through the risk management process in order to identify all the risks that could arise through the lifetime of the project. We then began to specify the more severe risks through the risk assessment step. To thoroughly decide which risk posed the greatest threat, we created a failure mode and effects analysis chart. We found the risk priority for each risk. These are the top 3 risks we came across and their associated risk priority number, and both a mitigation and contingency plan for each. So geological risks include cave-ins and unexpected rock formations. They had a high severity to the success of the project. They were also expected to be somewhat likely due to the fact that it was the deepest and longest tunnel ever built. And finally, it was hard to detect such events, even with all the geological tests that were run. So to mitigate this, you could run extensive geological tests before digging. And as a contingency plan, you could have trained medical staff on site and also find a new route for the tunnel. Financial risks include loss of funding or market collapses. They would have devastating effects on the project, however it was seen as not too likely to happen throughout the course of the project. These risks would be easy to detect due to the careful monitoring of the project's balance sheet and market conditions. So to mitigate such risks, you could have formal written contract with organizations funding the project, and as a contingency plan you could source public funding for additional funds, and remember, do not sacrifice quality for costs. Temperatures had the potential of running up to 50 degrees Celsius while working deep in the tunnel. This would cause work to slow and potentially come to a halt. It was seen as a mid to low severity on the success of the project, and almost certainly was going to happen. It was estimated to occur even before the project started. So to properly reduce the chance of these risks hindering the work, one could provide workers with lightweight, breathable gear and equipment. And if temperatures in the workspace got to these high temperatures, you could have fans and air conditioning units installed into the tunnel.
Strengths and weaknesses. First, a very important factor is that the owner of the Gotthard-based tunnel has an experienced project management team. The team had been proven by earlier projects that they are able to carry out such projects with schedule, budget, and quality requirements. Therefore, during the pre-planning stage, occupational health, quality, safety protection, and risk management had already been considered. According to length and complexity of the tunnel, the project team had worked with incredible precision, so they managed to finish the whole project on time with only 21% over budgeted, while had 2,600 people from at least 4 different countries working at the same time. Furthermore, the project team collaborated with research institutes to develop their own track system to avoid shadow traffic and to deliver the necessary materials. And this track system allowed the next team of contractors to install the railway technology on the finished tracks. Also, they made the working went on 24 hours a day. These are the reasons the team did an excellent job on making the project on time. Another detail shows that the project team had a realistic plan and a strong control on it. Until 2014, 2 of 7 predicted geological difficult zones were completed successfully. In addition, a proven and fair contract concept between client and contractors is also essential to avoid legal conflicts in the case of variation orders. Especially in tunnel construction like this, a poor risk management and unclear wording of contract could cause additional costs and delays. But the project team of Gotthard-based tunnel ensured the policies are clearly worded and leave no room for ambiguities. However, the project management team needs to be more aware for safety issues. 9 workers died during construction. In June 2000, a worker from Germany was the first victim of tunnel construction. He was hit by a boring bar that fell 700 meters, and there were 2 workers' deaths related to a colliding mine train. The last accident happened quite recent, in 2012. A worker from Italy fell from a scaffold. Although in a 17 years long project, only 9 people dead by accident is not so hard to accept. But still, the number can be reduced if the project management team did a better job on safety measures. Overall, the project management team got more strengths than weaknesses, and they won the Project Excellence Award in 2015. The major strengths of the project team include planning, scheduling, budgeting, and even contracts wording. But still, safety is something they can work on to improve.
Due to the cost of the project being the accepted criteria in the project priority matrix, the project was over budget by a significant amount. The initial estimates were projected to be 6.3 billion Swiss francs, and instead ending up being 9.5 billion as per the final cost projection in 2015. This is noticeably different than the 21% over budget previously mentioned, but these higher numbers were calculated without adjusting for inflation and on a project that was not very standardized when it came to pricing estimations. This project was financed with revenue provided by taxes. The majority of it, 64%, came from the HVT or heavy vehicles tax that was levied on heavy vehicles transporting commercial goods. Value-added tax, or VAT, provided the next largest amount of 23%, followed up by a petroleum tax of 13%. This project had a very long timeline, which makes the completion ahead of schedule even more impressive. From the initial sketch in 1947 to when the Swiss citizens voted to actually start on the project in 1992, up until construction actually started in 1999. The actual construction time of the project took 17 years, and they finished ahead of schedule, allowing for an additional 6 months worth of testing before it opened for general use. This was likely a result of them valuing time as the enhanced criteria in the project priority matrix. The objective and the main constraint of this project was to focus on quality provided. They focused primarily on this by improving several different aspects. First, they wanted to allow the travel of trains that could safely go over 250 kilometers an hour through this underground tunnel. Second, they wanted to increase the amount of freight by train through the Eurozone, and specifically Switzerland. And third, they wanted to decrease the travel time for passengers traveling between Zurich and Milan. In 1994, the citizens of Switzerland voted on the Alps Initiative, which was to move freight transport from trucks, which are not environmentally friendly, to electric trains. This base tunnel allowed the villages in and around the Gotthard Pass to experience a reduction in air and noise pollution. This project also improved the annual commercial transport capacity from 20 million tons to 50 million tons. Stakeholders were also satisfied by having their commute time from Zurich to Milan reduced by 25%, cutting 1 hour off of their total travel time. When the project was finally completed, it was terminated by integration as the primary construction company, Alp Transit Gotthard, is a wholly owned subsidiary of the Swiss Federal Railways. Overall, this project required 4 million man-hours and 28 million tons of excavated rock. It came in on schedule, but over budget and with a high number of casualties. Within the first 6 months of operations, this Gotthard base tunnel allowed 67,000 tons of cargo on 120 trains and transported an average of 9,600 passengers per day. For being the longest and deepest car and train tunnel in the world, we consider this project to be a great success.
When it comes to the recommendations and lessons learned, 2 areas that left room for improvement were basic safety training and looking forward at changing technology. Of the 9 deaths that occurred during the construction of the Gotthard base tunnel, none were a result of the project itself. All were caused by standard hazards that could have been found at any construction site. This is simply unacceptable and the reason to continually improve safety training. Technology can also become outdated quickly, especially with a project that spans 17 years. Some elements already installed had to be replaced before operations began in order to meet increasingly more sophisticated technical requirements. Areas that the Gotthard base tunnel thrived in were its team cohesion and the time and energy that were invested in the planning of the project. Over the course of the project, 4 countries and numerous areas of operations, including construction, engineering, geology, and Alp Transit, worked side by side with one another from start to finish without any organization leaving the project. Before construction began, numerous seismic tests were run and over 7 kilometers of drilling was completed to see what they were up against. Once construction was completed, 3,000 trials were ran before the rail line was opened for use. Lastly, a greater emphasis needs to be placed on the engineering profession. With more and more mega projects being undertaken around the world, it is important that there is a sufficient number of capable engineers who can take on these tasks. Looking at Switzerland specifically, out of the 4,000 projects that occur each year, only 3,200 of them can be taken on by Swiss engineers, while the remaining projects have to be outsourced to other countries. This can prove to be costly, and with more and more mega projects occurring, more engineers will be needed to make them happen.